Hey everyone, welcome. Steve here, and this is a work in progress on the master grade ball. So I started this project actually quite a while ago, I think, and I'm kind of getting down to the final stretch. I was planning to weather it this weekend and do all that, but my supplies did not get here, so instead I will be finishing up all the LEDs. So I thought I would do a video on that. This kit is very complex, and to light it, it has been very I don't want to say difficult, but it is definitely a challenge. I'm using a huge variety of LEDs, many different voltages and sizes and colors and stuff, so wiring it up has been kind of complicated. So what I'm doing now is kind of finishing that up, and what I need to do is actually create a little schematic, because I don't really remember what all these LEDs are, like what their voltages are and everything, so I need to create a little schematic to be able to wire this up. And I'm going to run it off of 5 volts. I've got this cell phone charger, and it's got a little adapter, so I could plug it into the wall, or I could even plug it into the computer to power it, which is super awesome. And USB is really easy to work with. The wires are typically pretty good. So that's the plan. So to get started, we've got my 5 volts. Alright, so using the diode function of my multimeter, what I'm going to do is record all the voltages of all the LEDs I am using. So 2.5 for the blue. Let's call that 2.5 through 2.8-ish. So next is the green LED in the cockpit. .6. And after measuring all these LEDs and figuring out exactly how bright I want them, the forward voltage of these LEDs is probably like, on these like 3.2s is like 2.8 volts, but to get the brightness I want, it's gonna run them at like 3.2 volts. And a lot of these LEDs actually have a lot in common. So here we've got the 3 for the verniers, so the 2 right here, and the 1 that goes in this bottom section here. These 2.8s are the these guys, these little surface mounts, which go inside these, which are these little side things that have these little clear plastic parts over them, which reminds me I've got one more 2.8 to worry about, which is the cockpit one. The 2 3.2s are the ones in the headlight. They could be run at like 3.4 volts, but I want those to not be so bright. And I've got 2 2.2 volt green LEDs, which are the ones that are in here, they are not as bright as the other green ones, but their voltage is lower, so I can actually run those in series. And then that 2.8 for the cockpit. So looks like I'm going to have to run all these guys in parallel, and I'm not going to be able to put any of them in series, which is okay, I guess, but it means I'll have a lot of resistors, and it's going to generate a lot of heat as well, so I have to be careful. So let's figure out what we need for resistance. So we've got our 5 volts. So 5 volts minus 3.2 is 1.8. So how much resistance do I need to dissipate 1.8 volts of electricity into heat? And to figure that out, we're going to use R equals V divided by I. And we know the voltage is 1.8, and we know the forward current of the LEDs is 0.2 milliamps. So R equals, I need to break out a calculator, and I actually wrote that wrong, so 20 milliamps is 0.02 amps. So we're going to do 1.8 divided by 0.02. That gives us 90 ohms. So R equals 90, and you want to find a resistor 90 ohms or higher. You don't want to go below 90 ohms, and I don't think there's a 90 ohm resistor, so you're going to have to round up. So R equals 100 ohms, and so I'll be using 100 ohms on all of the 3.2 volt batteries, or 3.2 volt LEDs. And now for the 2.8 volts, so 5 minus 2.8 equals 2.2. So R equals 2.2 divided by 0.02. R equals 110 ohms. So I need a resistor 110 ohms or higher, and the closest value of that is probably 120, but I'll see what I have. So somewhere in that range. I'll probably go a little higher just to be safe on both of these, so I'll probably do probably 120 on this guy, maybe 150 on this guy. We'll see how bright that looks when I test it out, but that should be fine. And if this is all a little too complicated for you guys, there's always a resistance calculator, which is doing the same thing I'm doing here, and it's a lot easier to use. All you do is punch in your values. So unfortunately I do not have as many axial resistors as I should have. I keep running into the same problem where I don't have the value I need, so I've got to order some more resistors. But that's probably a good thing, because I do not want a lot of resistors soldered onto a bunch of wires just kind of floating around in here, because it's going to create possible shorts. So what I'm actually going to do is I'm going to create a little board here and solder on my resistors to this, so I can just tack on wires onto this and not have to worry about a bunch of free-flowing wires getting twisted and shorting out. So I'm going to do that. I've got 120 ohms here, and we've got 100 ohms here, and I mean, I've got pretty much any value I need in surface mount, so we're in pretty good shape. So I'm going to go ahead and do that, and it's pretty simple. What I'm going to do is I'm going to cut this trace using a razor, just so there's nothing connecting it, and then solder on a resistor across to where I cut. And that looks pretty good. I've cut the traces so there's no connectivity. And if you always want to test that, take your multimeter, set it to ohms, and turn the speaker on. So we're good. Now what I'm going to do is I'm going to solder my resistors on over this section where I've cut, and hopefully I got enough. We got 1, 2, 3, 4, 5, 6, 7, 8. We need 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. So what we're going to do is I'm going to do this series separate. That's a little 30 ohm resistor that I'm just going to probably do a little axial, one of these type, and have that free floating. But for this one I'm going to do 1, 2, 3, 4, 5 of the 100 ohm, and then 3 of the 120 ohm, 110 ohm. And to test it, make sure it's soldered on correctly. Turn on the ohm meter, and stay 120 ohms. So we are good. Alright, so I'm getting ready to test out the brightness with these resistors. So I've got one of the green LEDs in this little side window, and I've tacked the negative wire to that resistor. And what I've also done is I've connected all of, or not all of them, but most of them, all but these two, over here using a terminal from a LED. So this way I can run a single wire off of this to supply my voltage. The reason I separated these two is I'm going to have the headlights, these on a separate switch, so I can turn those off if I want to, turn them on. It's just a cool little extra feature, so I got a separate little set of resistors for that. And yeah, so what I'm going to do is I'm going to tack on a magnet wire onto this, and then test out the brightness. So I thought I'd show you guys how to work with magnet wire. So magnet wire is a piece of wire with an enamel coating over it, and to be able to use it you need to remove that enamel coating so you can solder to the wire. And to remove it, what you do is you get a little ball of solder on your soldering iron, and you just kind of dip the wire into that solder until it heats up and melts, and then you should be able to just kind of wipe off that enamel coating. There we go. And I'm going to go ahead and solder that to my board. Alright, so the way I did the verniers is I coated the terminals with this liquid electrical tape, which is just an enamel coating just like what's on this magnet wire. And I drilled a 3mm hole over the vernier so that it'll fit on there like so, and drilled a hole through this part so I can feed up the terminals through there. Now what I'm going to do is epoxy that into place, and need something to mix the epoxy on, so I'm just going to use a piece of tape. Mix that up, and we're just going to go ahead and apply a bit, not too much. So I've got that put together. I made a mistake and did not include this little rubber piece which is supposed to go between these two parts, but no big deal. So trying to get everything kind of in place. What I need to do now is figure out how I'm going to actually close everything up. I've got wires coming in from tops, front, back, sides, and the bottom, and all needs to get connected inside here and then closed up, and I've got like bottom parts, so it's going to be very difficult to get everything assembled nicely, but that's what I'm going to work on and go from there. And I've finished soldering everything together. Get up close, and we'll get up close and see what it looks like. It is a mess of wires and everything. So I ended up using a little surface mount resistor, little 30 ohms, I think, or maybe like 45 ohms or something, for the LEDs and the cameras there. I've got 3 positive leads here. One is for the headlights, and the other 2 are the positive leads for this half and the other half of LEDs. And there's just 1 negative lead for everything, which comes off that board where I've connected everything there. And what I need to do now is just test, make sure everything is still working at the 5 volts, and then try to get it to close. That could be a difficult challenge. I'm also going to use some liquid electrical tape to cover any solder joints that may be floating around that may short out if they get touched to something else. So other than that, just about finished. I just gotta test to make sure it works. So we're gonna go ahead, grab my negative lead, connect that. Click on 5 volts. And let's get testing. Right, so those 2 are working. Can't light, or the LED up there is working, and the other side is working as well. Awesome. Let's test the next one. And this one's working, and so is the cockpit LED, and so are the camera LEDs. Those are pretty dull. I probably should have used the same LEDs as the other ones, the other green ones I used, which are a lot brighter. So that one works. Now to test the headlights. Gotta find the right one because I just mixed up my wires. And I figured it out. So when I had wired up these, I wired them up backwards. So I have 2 different colored magnet wires. I've got red and green, and on these I had used the red for the negative side and the green for the positive. And since then I had switched to using green on the negative and red on the positive for everything else. So when I wired it up, I had wired up these 2 backwards. So what I did, instead of tearing this apart and rewiring the insides, I actually just desoldered the LEDs and flipped them around and very, very carefully resoldered those back in there. So hooray, everything is working. Now I just need to get it the rest of the way put back together. I need to get this on which is going to require lifting this up, and hopefully I can do that. And yeah, we can finish this guy up. And there we go. It's all lit up. Now, I really wish I had used the brighter green LEDs on the cameras, but overall, it's okay. Turn out the light and really see how awesome these look. Alright, so now I need to finish putting it together and painting it. I got a few little details I want to paint up, and then I need to start the weathering process. And for that, I'm just waiting on supplies. I'm waiting on some oils that I'm going to be using to fade the paint. But until then, I'll just keep working on getting the water slides on and just painting some of the finer details, like on the arms here. I'm gonna paint some more chrome on those little circles and stuff. But yeah, I'm very happy I got the LEDs put together, and yeah, thanks for watching. We'll see you next time. Bye.